infinity, 0 to the power 0, and infinity to the power 0. These are called power indeterminate forms. Assume the limit as x approaches a of the function f raised to the power of the function g has the indeterminate form 1 to the infinity, 0 to the 0, and infinity to the power 0. Steps to find the limit of this form. First, let y be the function f raised to the power as a function of g. Then the natural log of the y is g multiplied by log f based on the power property of the log, as the natural log of x to the power r equals r times natural log of x. From the power form, now it becomes the product of the g and the natural log of the base function f. And then we are going to evaluate the limit of the log y on the left hand side. That means we find the limit of the product of the g and natural log f. After we get the value of the limit, we use this limit value as the power of the e to bring back to the limit of the original form. Example, limit of x to the power 2x. This time the function f is the x and the function g is 2x. First, let y be x to the power 2x. Take the natural log both sides. Natural log of x to the power 2x. We get 2x multiplied by natural log x. Next, we're going to find the limit as x approaches 0 from the right of the natural log y, as well as find the limit x approaches 0 from the right of the 2x multiplied by natural log x. Check the value as x approaches 0. The 2x approaches 0. The natural log x approaches negative infinity. This time we have the product indeterminate form. Now we are going to change the product into the quotient. The 2x can be rewritten as 2 divided by 1 over x multiplied by log x. That means we can find the limit of the equivalent expression as 2 times natural log x divided by 1 over x as x approaches 0 positive. Check the indeterminate form. As x approaches 0, the natural log approaches negative infinity. The 1 over x approaches negative infinity, positive infinity, sorry. So then we get the quotient indeterminate form as infinity over infinity. As we find the limit of the derivative of the numerator divided by the derivative of the denominator as x approaches 0 positive. The derivative of 2 log x is 2 times 1 over x. Derivative of 1 over x is negative 1 over x squared as x approaches 0 positive. Simplify this expression to be 2 over x divided by negative 1 over x squared. We write as a product of the reciprocal, or 2 over x multiplied by negative x squared over 1. After we simplify, the expression becomes negative 2x. As x approaches 0, the limit becomes 0. Recall the left-hand side is the limit of the natural log y as x approaches 0 positive. Therefore, the limit of the y as x approaches 0 positive is e to the power 0 or 1, where y is the original function, which is x to the power 2x. This example, we have the limit as x approaches 0 of the quantity e to the power 5x plus x raised to the power 1 over x. As x approaches 0, e to the power 5x approaches 1, x approaches 0, 1 over x approaches infinity, as we see as a whole expression approaching the value 1 to the power infinity, which is one of the power indeterminate forms. Let y be e to the power 5x plus x, all raised to the power 1 over x. Take the natural log both sides. To get 1 over x times the natural log of e to the power 5x plus x, or we write it as a quotient as the natural log e to the power 5x plus x divided by x. And then take the limit as x approaches 0, both sides of the equation. Check the indeterminate form of the expression on the right-hand side. As x approaches 0, the numerator approaching the natural log of the 1, which is 0, and divided by 0, which is one of the quotient indeterminate form that we can apply the L'Hopital. So the next step, we are going to find the limit of the derivative of the numerator divided by the derivative of the denominator. For the derivative of the numerator, we apply the chain rule. The outer function is the natural log, so then the derivative is 1 over the quantity behind the natural log, and then multiply by the derivative of the inner function, which is the derivative of e to the 5x plus x. So we get 5 e to the 5x plus 1. Denominator, the derivative is 1. Simplify it a little bit to get the natural log as x approaches 0 of 5e to the 5x plus 1 divided by e to the 5x plus x. Check the indeterminate form. As x approaches 0, the numerator approaching 5 times 1 plus 1, which is 6, divided by e to the power 0, which is 1 plus 0. So then overall, it approaches to the value 6, which is the result. So then this limit approaching to the value 6, which is the limit of the natural log y as x approaches 0. We are going to change it into the limit of the y. That means we're going to use 6 as the power of the e. And the y is the expression e to the 5x plus x raised to the power 1 over x as x approaches 0. So the answer is e to the power 6.